Okay, good morning to everybody. Today we'll start a new part, the Laplace transformation. This is one kind of integral transformation. In our previous lecture, we discussed the integral, what is integral transformation, then what is Fourier series, and what is Fourier transformation. Then today we will start a new part, what is Laplace transformation. Okay. First of all, the definition, what will be the Laplace transform? Definition. What is Laplace transformation? Suppose any function, let f be a function on an interval 0 to infinity. Okay, this will be like this: 0 to infinity. The Laplace transform of the Laplace transform of f is the function capital F defined by the following integral. Zero to infinity e to the power minus st f of t dt. This is an improper integral. Here the domain of the capital F function is the set of all values of S for which the integral converges. The integral converges. That means we get a value of the integral. The Laplace transform of Laplace transform of f denoted by in another way. Here in the following, I am discussing about this. So actually, Laplace transformation is a improper integral. So it can be written as like this: Laplace transformation of f of t. Laplace transformation of f of t. This equals to f of s. Same words. Okay. So the Laplace transformation of f of t can be denoted by f of s. F of s means this integral. Okay. 0 to infinity e to the power minus st f of t dt. But you have to remember that this is the original function. Okay. This f of t is the original function. And this f of s is the transformed function. Okay. Transformed function. So here f of t, here f of t is the original function. Remember it, original original function, original function. Okay, original function. And if we write like this, suppose f of t e to the power minus st, this whole is the transform part. This is the transform part, this. Okay, and s is the parameter. Here s is the parameter. So we have to remember this three part. One is this, the f of t is the original function, and this also a original function, this two, and s is the parameter, and e to the power minus stf dt is the transform part of this original function f of t, small f of t. So this is the main definition of Laplace transformation. So the Laplace transform, in this definition we got f be any function and its Laplace transform is denoted by the corresponding capital letter f. And another notation is what? Capital L f of t. Okay. The input to the given function, that means independent variable. Input means what? Independent variables. We denoted by what? Small t. And input to its Laplace transform f is what? Small s. So inputs for the transform function will be s, that means parameter, remember it. And small t is the what? Input for the, that means independent variable of original function small f. And small s is the what? Parameter of the or domain of the transform function capital F. So by default, the domain of the function small f, that means f of t, is the set of all non-negative real numbers. We have to remember that this will be all non-negative real numbers. That means t will be greater or equal to 0. The domain of its Laplace transform depends on f, small f, and we can vary from a function to a function. So that in this case, the definition I have written like this: the Laplace transform f of s of a function f of t can be denoted by like this. Okay, so the integral is evaluated with respect to t. Hence, once the limit are substituted, what is the left are in terms of s. Actually, this s is the parameter. Okay, now we will discuss find the Laplace transformation of the constant function f of t equals to 1. Now I am trying to solve this one. What will be the Laplace transformation of constant function? Okay, that means what will be the Laplace transformation of 1? Laplace transformation of 1. So, for example, what is the find the Laplace transform of the constant function? Find the Laplace transform of constant function. Okay, constant function. Constant function means what? F of t equals to what? 1. Where t lies between 0 and infinity. Okay, so the Laplace transformation, we know f of s equals to what was by the definition? F of s equals to 0 to infinity small f of t e to the power minus f st f of t dt. Okay, so here f of t equals to what? 1. That means 0 to infinity e to the power minus st 1 dt. So what will be the e to the power x formula? What? e to the power x formula what? Can you tell me? E to the power x formula, e to the power x. Okay, but you have to divide with the coefficient of t, that means minus s. Then you have to put the limit within third bracket. So minus s. Now putting the upper limit e to the power, this is the t values, upper limit t equals to infinity. Then we get e to the power minus infinity. Okay, e to the power minus infinity. That means what? E to the power infinity. 1 by e to the power infinity what? In 1 by infinity. That means 0. Okay. So we get what? 0 for upper limit from here. Okay. Upper limit. Then e to the power 0 equals to what? 1, right? E to the power 0 means 1. That means we get only 1 by s. So the Laplace transform of a constant function f of t equals to 1 will be what? 1 by s. You have to remember this. Now another example 2. Another example 2. Find the Laplace transformation of what? T to the power n. That means f equals to what will be? T to the power n. And t greater or equal to 0. That means t lies between what? 0 to infinity. In the definition of Laplace transformation, the independent variable of a small f will be non-negative real numbers. This is why t lies between 0 to infinity. And we know this is the definition of what? Laplace transformation. Now just putting the value what? T to the power n. Just putting the value of t to the power n, we get these values. So we have to find the integration, that means improper integration of this. Now we have to substitute this, put st equals to x. Okay, just substituting st equals to, so t equals to what will be from here? T equals to x by s. Now dt equals to what will be? dt equals to will be dx by s. That means the the variable, the input variable t transformed to x. Okay. Now substituting here, the limit values will be also same, because this is the 0 to infinity. This is why the limit value will be same. So Laplace transformation of f of t equals to will be this, and Laplace transformation of t to the power n, because f of t equals to t to the power n. So 0 to infinity e to the power what will be? Minus x, and t equals to what will be? X by s whole to the power n. dt equals to what will be? Dx by s. Now we have to find this improper integrals. Now here s to the power n, 0 to infinity, s to the x to the power n divided by s to the power n, s to the power n. Okay, 1 by s dx. So this is the integration with respect to x. So s will become constant, s to the power n, s to the power n into s. What will be? S to the power n plus 1. So this is the 0 to infinity e to the power minus x, x to the power n dx. Actually, you must know about gamma beta function. So this is the formula of gamma n plus 1. 1 by s to the power n plus 1. This is the formula of what will be gamma n plus 1. Gamma n plus 1. You must know gamma n plus 1 means what? Factorial n divided by s to the power n plus 1. This is the result for the Laplace transformation of t to the power n. So just using the definition of gamma function, gamma n equals to what was? Gamma n equals to 0 to infinity e to the power minus x, x to the power n minus 1. So gamma n plus 1, what will be? Gamma n plus 1 will be, gamma n plus 1 will be 0 to infinity e to the power minus x, x to the power n plus 1 minus 1. That means x to the power n, okay? By the definition of gamma function, we can use this integral. We know another one, gamma n plus 1 equals to what? Factorial n. Remember it. Just using this concept, we can find the Laplace transformation of f of t, what? N factorial divided by s to the power n plus 1. Now another basic example, Laplace transformation of basic function. Example 3, find the Laplace transformation of e to the power at. That means Laplace transformation of e to the power at, where t non-negative real number, and f of t equals to what? E to the power at. So t lies between 0 to infinity. So we know from the definition of Laplace transformation, this f of s equals to 0 to infinity e to the power minus st f of t dt. So Laplace transformation of f of t will be what? F of t equals to what? E to the power at. Now just integrating, this will be the improper integrals. Okay, improper integrals of with respect to t. So we can write, this is the exponential function. Both are exponential function. E to the power, what will be? Minus t will be common. Okay, s minus a into t dt. So this term can be written as like this, minus s minus t. Now e to the power x formula what? E to the power x divided by with the coefficient of t. Now putting the upper limit and lower limit. So you must know integration of e to the power x, what? E to the power x divided by a. You must know about this integration just using this one. Now putting the upper limit, that means if t equals to infinity, e to the power minus infinity, we get what? E to the power minus infinity. That means e to the power infinity, 1 by e to the power infinity. 1 by e to the power infinity, what? Infinity. Okay. So 1 by infinity means what? 0. So putting upper limit, we get what? E to the power minus infinity. And putting lower limit, e to the power 0. Okay. So minus s minus a. This means what? 0. Okay. 1. E to the power 0 means what? 1. So we get 1 divided by s minus a. This is the Laplace transformation of e to the power at. So very easy. So now another example 4. Now we have to find out the Laplace transform of cos hyperbolic at, where t lies between 0 to infinity. That means t is the input of original function. Oh, and this is the original function and this is the transform function. Remember it. from the definition, we got this idea. So Laplace transformation of f of t will be what? Cos hyperbolic at t dt. So Laplace transformation of f of t. F of t means what? Cos hyperbolic at t. We must know cos hyperbolic at t equals to what? E to the power at t plus e to the minus at t divided by 2 by the inverse inverse trigonometric function. That means hyperbolic function. Okay, hyperbolic function. In our previous lecture, in the complex number, we have studied about this. So we must know we can transform cos hyperbolic at t equals to what? E to the power so 0 to infinity e to the power minus st into e to the power at dt plus 0 to infinity e to the power minus st e to the power minus at dt. There will be half. Okay, so this means what? 0 to infinity e to the power minus s minus a into t dt plus half 0 to infinity e to the power minus s plus a dt. Okay, so by using the previous example, we must know what's the value of this 1 by s minus a. Okay, by using example 3, it will be what? 1 by s plus a by using example 3. So taking half common and s minus a s plus a s minus a will be what? LCM. So s plus a plus s minus a. So a will be cancelled and twice s divided by 2 what? Only s. So s square divided by minus s square. S square minus s square. That means Laplace transformation of cos hyperbolic at equals to what will be? S divided by s square minus s square. You have to remember this. Similarly, we can find the cos Laplace transformation of sine hyperbolic t. Similar process. So this will be the example 5. Sine hyperbolic t. Sine hyperbolic at what will be? Just using sine hyperbolic at, and this is the transform function by the definition of Laplace transform. So sine hyperbolic at what will be? Sine hyperbolic at. So this will be what? Just minus, because sine hyperbolic at equals to e to the power at minus e to the power at minus e to the power minus at. Okay, just using this concept, we can find this same result. Okay, Laplace transformation of what? Sine hyperbolic at. So this, there will be only just negative sign change. So we get what? Taking LCM minus, this will be plus. Okay, so in this case SS will be cancelled twice a. So there will be what? A divided by s square minus s square. Same result, similar result we got. So the Laplace transformation of sine hyperbolic at will be a divided by s square minus s square. But the Laplace transformation of cos hyperbolic at what was? S divided by same denominator. Very easy for you. Very easy example. Sine at. What will be the Laplace transformation of sine at? Okay, Laplace transformation of sine at. sin at. So this is the transform function. So Laplace transformation of this will be what? Sin at. But sin at formula what? Sin at e to the so in circular function you must know about this e to the power iat minus e to the power minus e to the power minus iat divided by twice I. Okay, from previous lectures you must know about this formula. So iat and this will be minus iat divided by twice I. Okay, so using the same concept there will be what? I. Okay, and there will be minus I. Yes, there will be IAT and there will be minus IAT. So integration, what will be? S minus, what will be S minus IA. Here will be S plus IAT. So integration, what will be? Integration 1 by IA minus half. This also S plus IA. S minus IA. Another one is S plus IA. So half will be common. Then taking LCM, S plus IA, S minus IA, what will be? S plus IA minus S minus IA. So from this IA, SS will be cancelled. So we get IA divided by what will be S square minus I square A square. Okay, minus I square equals to what? 1. This is why minus minus plus S square plus A square. Okay, but there was twice I. There was what? Twice I. Okay, twice I. So similarly, we can find the Laplace transform of cos at, where the independent variable of original function f of t will be non-negative real numbers, and f of t equals to what? Cos at. So we must know the formula in the exponential form of cos at. What will be? E to the power iat plus e to the power minus iat divided by 2. You must know about this formula from our previous lecture of complex numbers. In complex numbers, we have studied about this. So just using this formula, there will be changed and this will be cos at, just substituting this formula here. So this will be minus 1 by 2, only 1 by 2, and there will be plus only. Okay, plus. I will be absent for cos. So I will be absent and there will be plus. So